Hello, everyone. We are the Network to Code and Arista Capstone. I'm Cody Donovan.
I'm Vincent Klannerman.
I'm Cade Sherry.
I'm Tyler Lee.
I'm Caden Struey.
And I'm Jonathan Harlfinger.
Our roles and responsibilities for our project. I was the project manager. Vince was our Google Cloud specialist. Tyler was our Naudibot engineer. Caden was our automation engineer. John was our telemetry solutions expert. And Cade was our network engineer and secretary. So our sponsors, our first one was Arista Networks, and they gave us the virtual lab environment that we used throughout our entire project. And our second one was Network to Code, who gave us Naudibot, which we used to manage this network and the virtual environment and made it very easy to use. So the challenge that we had was to create a lab that had a golden config and a single source of truth with Naudibot as the main component. We also had to use dynamic inventory with Ansible and use a continuous integration pipeline.
All right, our environment overview. We utilize Google Cloud to host our entire environment. Arista, like Cody said, was our networking side of things. Container Lab hosted the virtual Arista devices. Naudibot connected everything together. We used a chat app solution, specifically Slack, to kind of query Naudibot without having to go into it. Ansible for automating, GitHub to hold all of our code, and Zabbix for a telemetry solution, and then Docker we use to containerize everything together. Google Cloud, like I said, hosts our entire environment. It allowed for ease of accessibility, very easy to use interface if you used any cloud formula out there. Very collaboration oriented. We were able to all use it at the same time, and it made our environment scalable and modular.
Our lab environment ended up being pretty simple overall. It was a spine leaf design layout with 2 layer 3 switches, 4 layer 2 switches, and a host on either side of the network just to simulate connectivity. And so the basis of our network was Naudibot, which is if you go to the Network to Code website, right on the front page, they'll talk about this quote I feel is really important, is at its core, Naudibot is a single source of truth that defines the intended state of the network. And then right below that, they talk about like the use case of eliminating spreadsheets, which is like, you know, a huge thing of, you know, maybe we've all been there of working on a project and you're going through 3 or 4 spreadsheets trying to find some crucial piece of information. And I think eliminating that is like a great thing. So basically, like I said, it functions as a connector for achieving network resilience and consistency. It's also open source and acted as the centralized network management solution that we used for management and configuring.
So let's dive deeper into single source of truth. Now, if there's one thing I want you guys to take away from this presentation, it's single source of truth. We want one place where you can get all the information you need about your network. If you want to know the IP address management, you go to Naudibot. You don't have to use something like Microsoft's IPAM solution or Efficient IP as your IPAM. Another thing is if you want to know where all your devices are located in your data center, where exactly in the rack it's located, Naudibot can tell you that. If you know the current network configuration that devices have, it's all there. And then another thing that Naudibot can do is, let's say that you have lots of WAN providers and you have information about all those different WAN circuits all over the place in different spreadsheets, like Cade was saying. You can put them all into Naudibot and it's all on one page for you. Golden Config was one of the plugins that I added to Naudibot. And the great thing about Golden Config is it allows both backup and compliance for your network devices. So you can run a backup job on your network devices and it will automatically back up the running configuration to Git repository. And then you can also create templates for your devices and run compliance jobs to make sure that your devices are in compliance with the configuration that they should have on the network. Another plugin that I added is Chat Ops. This allows you to install the web GUI for Nautobot. You can use a messaging app like Slack, WebEx, or Microsoft Teams to interface directly with the Nautobot app and get information about the network device.
So for our automation solution, we chose Ansible since that was what was requested in our statement of work. And this allows for a couple of different things. It allows us to establish a dynamic inventory, either through a regular API query or through a GraphQL query. It also allows us to have automated responses to various events on our network, allowing it to be self-healing if you have the response set up for the event. It also pulls from a centralized repository, being GitHub, and that is used to hold our playbooks, our configurations, other information that we'll need on the network that Ansible uses. Lastly, a huge thing of why Ansible was requested for this is because it functions in an idempotent manner, meaning that it only pushes changes to a device when changes need to be pushed. So if you want to assign a IP address to a interface, but that interface already has that address assigned to it, then it will just return back okay, and that the interface is ready to go.
So we were tasked with choosing a telemetry solution, and we chose Zabbix. But if you don't know what a telemetry solution is, it's basically all sorts of device statistics that your network switches, your routers, even host devices like servers and stuff generate. And Zabbix is a central place where you can collect and index the data and are able to view it in an easily formatted manner. And Zabbix allows you to create things like alerts. So if your network switch goes down, or maybe even something as small as a server fan fails, Zabbix can create alerts for network administrators to view and also keep track of problems. And it can also do other stuff like sending these alerts to your existing ticketing system or emails or instant messaging. The reason why we chose Zabbix was just because it's an open source platform and also is right now a huge industry standard for a lot of companies utilize it. And it's also natively supported for EOS and our Arista devices.
So like we've mentioned before, we used GitHub as our central code repository, and this allows for a couple different things. It allows us for collaboration, no matter where any of us are, as long as we have internet connection, we can upload code to there and work with the repository. Like I mentioned about working from anywhere, it's remote. You don't have to be with the group to necessarily get work done, even though that's definitely an option you have and beneficial sometimes. So additionally, it stores our playbooks, backup configurations, all that information used. And a big thing about GitHub even is it tracks the changes to the files, so it allows for a self-documenting process of who changed what when.
Another big element of our project plan was the continuous integration policy. Effectively, or essentially, we wanted to make sure that what we were doing on this project was up to a certain standard, that what we're putting out onto the world in terms of our GitHub page is like up to what we want to be putting out there. So our policy essentially was that you needed to start on a forked branch initially. You then needed to score at least a 90 out of 100 in Pylint or Yamlint, and then it needed to be reviewed by another team member before it could be merged into the main branch. Once you did all three of those things, you merge it into the main branch, and if problems arise, problems arise. But the whole purpose is, again, we want to make sure that we're not just deploying things to main willy-nilly. And overall, the continuous integration policy was just one part of our overall testing policy to make sure that everything is working and everything is up to a certain standard.
So there are some challenges that we had to overcome as we were building this capstone. The first was building containers. I know that learning virtualization here at Stout, we mostly focus on virtual machines, but using Docker to create containers is more efficient because if you were to create a virtual machine for every service that we used and put it on Google Cloud, it would have cost a lot more money. Another challenge that we had to overcome was the Slack to Nautobot connection. I haven't really worked with APIs before, so learning how to add API keys to Nautobot so that I could interface with Slack as an app was something new that I had to learn. And then another thing that we had to overcome was the EOS modules for Ansible. When I've worked with Ansible, it's mostly been with Cisco devices. So transitioning to EOS, we had to figure out what the best way was to deploy with Ansible with the EOS modules. And then finally, as for team communication, we mostly worked on this remotely. So remote work is great because you can work wherever, but it does come with the downside that communication can be harder. So we had to learn to work together remotely and grew to work better together as a result.
So we're going to give you guys a live demo here. First, we're going to show you our Google Cloud Console, and then we'll be showing you our topology for our virtual environment, so how our Nautobot works and how Slack communicates with it, and then we'll give you some Ansible commands and show you our Zabbix.
All right, this is our Google Cloud dashboard. That VM right there is our entire environment. We were able to make it with one VM due to Docker. So they're basically lightweight images running on that VM. One of the reasons why we chose to use Google Cloud is then we didn't have to host it on a specific hardware device, having to come into school. This made it so we could work on it anywhere, anytime. It gave us a public IP, so the next web pages that you will see come from Google Cloud giving us that. And another nice part was Google Cloud has a free trial for 90 days and a $300 limit with that. Another nice thing was we were able to give everyone their own user account, so we weren't all stepping on each other's toes. And that was just kind of a nice way to bring everything together.
So here's our virtual lab environment. And again, it's very nice that we can all work on it together. It also shows just where everything is and how everything is connected because we don't have that physical equipment. And it's very easy to use. It's as simple as clicking on and SSHing into each device and logging in. Very secure as well. And then you can just make manual changes, and then later you'll see how we used our automation with Ansible when Caden starts talking here.
So here's Nautobot. The first thing I want to show is the sites that you can create. So if you have multiple locations, let's say you were a retail store, you could have a site for each of your stores. Or let's say that you are a manufacturing company, you could have a site for each building. Right here, we decided to make sites based off of data centers. And right here, we're looking at the Menominee data center. Another thing that we can look at is the devices themselves. So here we can see all the devices that we've added to Nautobot from Container Lab, and here we can see some details about these devices, like the role that they serve, the IP address we use to manage it, and the rack that's located in. And one of the things that I like about Nautobot is you can click directly on the rack, and then it will take you to that rack and show you where in the rack that device is located. So as you can see, they're all located at the top there because they're virtual devices. Now, if we go into the device, we can see some more details about the devices. And another thing that I like about Nautobot is you can give it some user credentials to log into the device. And if you go to configuration, we can see the running configuration of that device, because Nautobot can just query that device for the configuration, and it's all here for you to see. Another thing we can look at is the IPAM. Here we can define all the IP addresses that are on our network and what devices they're associated with. And then if we go to the circuits, so here are the WAN circuits I was talking about. So here we can define like the circuit ID and what provider they come from and what type of WAN it is, and then have them all in a nice list here for you to see all the circuits that your company has. The next thing we can look at is the compliance reporting from Golden Config. So when you run the compliance job with Nautobot, it will give you this nice report here showing you what devices on your network are in compliance with your templating and what ones are not. Obviously, all the ones that we've done are in compliance, so all you see is green. But if we had one that was out of compliance, then you would see red on the right of that green bar. Now, if we go to jobs, we can run a backup job just to show off the job functionality that Nautobot has. And we're going to run a backup job. And the nice thing about the backup job, or any job, is you can specify based on a bunch of different variables what devices you want to run the job on. So in this example, we're going to be running the backup job on the entire site. And then, as you'll see, it will connect to our GitHub repository, make sure that it can push to the GitHub. And then it's going to collect all of the configurations from those devices and then push it. Next, if we go to Slack, we can show off the chat ops. Here I've added the Nautobot app to our general channel of the Capstone workspace that I've created. And we use the /Nautobot command to query Nautobot. And right now we're going to be getting device facts about Leaf 4. So if we run that, it's going to give us a nice YAML format of all of the device information that Nautobot knows about that device. And then another thing you can do is you can get the device status. So basically, it'll just give you a yes or no, is this device online? And as you can see, it's active.
So quickly before I jump over to the laptop to show you some of our Ansible automation plays and the things you can do with that, I just want to walk you through our GitHub real quick. We have a README, all of the code, minus a couple files that have things like tokens in them, but those are included in an appendix on our documentation, so you can still view them if you would like. But this is the file structure you can see, holds files, it's a GitHub, nothing inherently out of this world. But while I pull up the console to show you these things, Cade is going to talk to you about why you might want to use a GraphQL query as opposed to a normal API query.
Thank you very much, Caden. The essential difference between the two is that a GraphQL query is going to be much more surgical in terms of what it's going for. We're going for something that's, you know, if you're going for like one single piece of data from a large section, you don't really want to be digging through a whole large amount of stuff in order to get what you're looking for. So with GraphQL, you're being more efficient with your network resources as opposed to a general API query. We're mainly looking to prevent overfetching or underfetching.
So now that we have the SSH window up to our VM, we can put in the command sudo docker exec -it, so the container that we are switching to will have an interactive terminal for us. After that, you can either put the Docker ID of the container or the logical name like Ansible container if you choose to do it that way. Then once we get into the container, we can change to our Capstone directory, which is our pulled down Git repository. then our Ansible core, and our GQL inventory file. In this, you can run if I could type it in, you can run our GQL inventory, which will pull down a GQL query from Nautobot. And here you can see, as some other groups have touched on before, the process of how Ansible runs. You can see the task that's running, the playbook that's running, and a recap of that. So this will pull down a JSON formatted file, and then we can use a Python file to pull out the information like hostname and IP address. Let's type something. Well, I'll give you a quick list here because the files are still here. So you can see that it would make a .ini file, which is readable by Ansible, and that is what is going to be used to connect to the devices themselves. Then we will go back one directory, and I will run a couple playbooks for you, one being user creation to show you just something you can do with this. In this command, you have the -u identifier, so you can specify a username to connect to the device, and the -k identifier, so the user will be prompted with a password to log into the device. You can see that we are prompted, the playbook starts, the task starts, and then you have to wait for a second. Now you can see that it connected to the Leaf1 device. It connected successfully, and it successfully changed something. Now, to show you a little bit of the idempotent manner of Ansible, we will make a VLAN on our device. Wait for that to run. And then you can see again, it connected to Leaf1. It connected successfully, and it changed something successfully. Now I will run that command again for you. And we can see, once it pops up, that now Leaf1 is green with a OK equals 1 in green and no changed identifier at all, meaning that it connected to the device, went to change and create that VLAN, but saw it was already there. So just return back. It's good to go. Nothing needs to be done.
So now we're going to go down to our last demo here, which is Zabbix. So this screen that we're looking at right now is kind of the main dashboard that you might get if you had a Zabbix deployment. This is kind of just a global overview of your entire system. So it gives you statistics about your server itself, how many of your devices are online and available, and it also gives you some problems that may be happening within your network. And as Cody just clicked on, you can take any of those problems that may be generated, and you can put messages, you can close them, you can assign them to different categories that may help other people be able to troubleshoot and deal with problems in our network. Another thing about Zabbix, or we're going to show another dashboard here, is the dashboards. So you can make any kind of customizable dashboard that you want to display anything you want. So up here I've got some more of those problems. I have a map that can show you where devices are on a map. So right now we're just have it set to be in here. And also you can have stuff like graphs. So these graphs are just displaying internet or network traffic across different interfaces. And if you want to hover the mouse over it, you can actually dive right into exact numbers for each one of those interfaces on all the different switches and stuff. Now, we added a lot of these devices manually because there was only a couple, but maybe you have a existing network that is really huge and you have a ton of devices. Zabbix allows you to do something called discovery, which allows you to automatically find and add any device within your network. And it may not even be a network switch, but if it holds characteristics or has statistics that maybe you're interested in, it can find that and pull that. So if Cody here shows the discovery tab, you can see that all of our devices have been added automatically because they were in the management network we have, and they also had some of the SNMP community settings that we set, which is basically what it checks for to see, is this device something that is within our network and should we have it in our list? So Zabbix is basically just a really easy way to monitor tons of information going across your network and can be a really fast and effective way to see problems and then deal with those problems. And with that, I'm going to hand it back to Cody for final words.
All right, well, we'll be finishing up here, but we just want to say thanks to Josh and Will from NTC and Arista for sponsoring us with this project, and Holly and Nam for giving us this class opportunity. And yeah, it was a lot of fun. It was a lot of work, and we all learned stuff. So we will now open the floor to questions.